Good morning, guys, or whatever time this is for you. Today we are going to go over a video that's going to prepare you for your final test. The final test is on the last day of class, so Thursday. Um, you don't have to take it until then. And so I just want you guys to be ready. There's, of course, the game review that you guys can do, but then this is also more specifically related to the um, the short answer part of the test. So I also included something at the end that you guys really need a review on. Okay, so here's my general information for you guys. You need to write in complete sentences. So you can write down a whole bunch of vocabulary words and not know what they mean. But if you can explain what those mean in a full sentence and relate it to other things, then I can tell that you know what you're talking about. And what you're really trying to do on a test is show me that you learned something. So I really want you guys to focus on writing as much as you can. Take your time. You have spell check on Google, so you can please use that. Um, I would suggest that you prepare in advance. So right now, while you're going through the slideshow with me, if you have time, you can just write down your answers like what you would write as a paragraph if we were in person in class, and you could write it down on paper. And then when the test comes, you can just type it into the boxes. So that's what I would do if I was preparing for this class, and I strongly recommend that you guys do that. Okay, one thing I've noticed a few times is that people are copying things from the internet. And if you copy things from the internet, that's cheating. I haven't been giving you guys zeros for the most part. I've been giving you guys a chance to, or especially if you're like a younger classman, I've been giving you a chance to like go ahead and just redo the assignment. If you're a senior and you know better, then you probably got a zero for cheating. It's really important not to cheat for a lot of reasons. There's the one reason that it's wrong, right? Um, you can fail the class if you cheat on your final. So I don't know exactly how it's going to work because you guys can work on your classes throughout the whole year. But if you cheat on this, then you will fail the class for now. I will give you a zero on the whole thing, the whole class. It's also not good to cheat because of your future. So if you are trying to learn something in class and you don't, or you're supposed to learn something but you don't because you cheated, then when you take like a standardized test down the line, and that's going to count for graduation, you're not ready for it because you didn't do the work now. So the work now is really important because it will pay off for you later when you're trying to get all your graduation requirements done. So write your answers right now with me, and you won't even have to cheat because you can just prepare right now. And then there's a lot of vocabulary words that are going to be used throughout the test, like on the multiple choice section, that you can use in the test. And that's the case with most science tests. So, well, actually, most in-class science tests. The SBA, like those standardized ones, they kind of make sure you can't do that. Okay, so the first question is, how did the universe begin and what evidence has been compiled by scientists to support the Big Bang? Okay, so the answer, and this could be your first sentence, is, well, what is the Big Bang? So the Big Bang is the beginning of time and space. It was when everything before that had been compacted into this teeny little unimaginably small and dense particle, and then it just started to expand. So that's what it is. How do we know it happened? Well, you can write down, we know it happened because the amount of hydrogen and helium, we can view the CMBR from the whole universe, and because everything is redshifted. But that is not 5 sentences, and you're not really explaining what those mean. So remember, when you're talking about the amount of hydrogen and helium in the universe, well, the reason that that supports the Big Bang Theory is because in the early universe, the whole universe was so small and hot and dense that it was acting like a star. And so the hydrogen was there because it had cooled off and the protons and the neutrons had captured electrons. But then, actually, they didn't capture electrons right then. Sorry, scratch that. So they had the nuclei, the positive and the neutral particles had formed into hydrogen, but because it was so hot, it was acting like a star. And for amount of time, that hydrogen was fused into helium. And so the amount of helium that we expect to be in the universe based on the amount of time that the universe was acting like a star, the whole universe was acting like a star, is the amount we observe out in nature. Okay. Next is the cosmic microwave background, and you could also put radiation. So I put CMBR right here, but in your test, you probably ought to put cosmic microwave background radiation. It'll probably be in the multiple choice section in case you forget, but you also have your notes with you, so you should be able to write out the whole word or the whole term. And that is this radiation that was put out into the universe in the form of microwaves. And it happened because the universe had been so hot and so dense. But then when matter started to capture those electrons after that, um, that energy that had been like stuck there was released all throughout the universe. It shows us that the universe is homogeneous and isotropic. So basically, isotropic means that the universe, if we look out, is basically the same everywhere. That's what homogeneous means as well. So we can look out into the universe and we see, like, even though that part is way over there, it's similar to this chunk right here. And that means that at one point they were both touching. And that shows us that it's been expanding ever since. And that it was once closer together. Okay, redshift, of course, Edwin Hubble is the one who noticed that redshift was everywhere in the universe. So pretty much everything he observed in the universe is redshifted. And so if it's redshifted, that means that the light is being stretched out. And so if it's stretched out, it's moving away from us. If it's compacted, it would be moving towards us, and we would call that blue shift. So since everything is going out away from us, if we played that backwards and we were trying to go back to the beginning of time, like we had a VCR of the universe. Oh, you guys don't even know what a VCR is. Okay, like we were rewinding the universe. I think you know what rewinding means. Then it would all come back together if we played it backwards. So it's going like this. If you play it backwards, it would come in. So those are the big three bodies of evidence that support evolution. I mean, the Big Bang Theory. It's 5 o'clock in the morning where I am. Okay. Explain how stars over their lifetime fuse elements found throughout the universe. And include how the original hydrogen and helium formed. So we have to talk about the original hydrogen and helium because stars can't fuse any elements if they don't have any elements to fuse. So remember to use the word fusion in here. I would explain that fusion is when you take two lighter elements and you combine their nuclei to make a heavier element, and when you do that, energy is released. So that's why stars can give out so much radiation. The original hydrogen and helium was formed during the Big Bang, or right after the Big Bang. And then the life cycle and the elements that happen at each of these stages. So of course, protostars, that's when the gas is collecting, but it's not hot enough to undergo fusion. So it's not making any new elements. It's just a increasingly hot ball of hydrogen and helium that will turn into plasma once it is like whacking against each other so hard because of the pressure and temperature. Main sequence stars are, of course, going to fuse everything up until iron, so 26 or below 26. And that's element 26. And so that's what main sequence stars do. Our sun is a main sequence star, so it's mostly made of hydrogen and helium, and it's fusing hydrogen into helium. But there's other elements in there as well. But as they get older, and our star still has like, I think like 5 million more years before it's going to become a red giant, so like we have a lot of time. Then that red giant star is where it expands, and it basically is just sitting there waiting to like die at that point. It's like really old age. And then we get all the rest of the elements in a supernova. Note, not all stars are big enough to have a supernova. So like our sun will never go supernova because it's not big enough, it's not massive enough. And so we will just have what's called a planetary nebula in our place in the middle, and then probably a brown dwarf or a black dwarf someday. The universe isn't even old enough to detect black dwarfs, so you don't have to include that in your paragraph. But if you did, you'd probably get bonus points. All right, question number 3. Explain solar weather and how the energy from the sun impacts the earth. So this is something that is in the standards that they think is really important. So we got to make sure we go over it. So how does the sun generate energy? Well, remember the sun is a ball of plasma. It's held together because these are gases, right? So we have hydrogen and helium gases that turn into a plasma. Plasma just means that the nuclei are together still. So you've got the protons and the neutrons. The nucleons are intact, but the electrons have like separated. So you have all this positive parts and negative parts that are like making it a charged gas. So it's not a neutral gas anymore. Now it's a charged gas. That's what plasma means. And in the core of the sun, we get fusion. And fusion, of course, is when you take two smaller elements, fuse them into a bigger element. And when you do that, energy is released in the form of radiation. So this is really important because radiation is also how the energy gets to the Earth. So there's a few other things like in the core, the energy is going to be released as radiation, but then it gets bounced around a whole bunch of times. And then there's like a convection layer, which convection, if you remember, is when the particles move up and they lose heat, and then they move back down when they gain heat at the bottom and then lose heat. And then so things are like pushing them around in these big cells. The temperature pushes these big cells of convection. So that's part of the sun too, but you don't have to write about that in your paragraph. How does the energy get to the Earth? Yes, it's also going to get here through radiation. And then you need to talk about the specific examples of the solar weather. So like remember the sunspots are where the magnetosphere is like pushing out in these big rubber bands through the surface of the sun. A coronal mass ejection is when like a hot ball basically of plasma gets shot out. That happens all the time. It's just that usually they aren't shot towards the Earth. When they are, it can really affect the Earth because we can have like our power go out. It did happen in Canada one time where their power grid was disturbed by a coronal mass ejection. And I don't know, that to me is like crazy. What would we do if there was no more? Like what would we do on the Earth if we did not have power for several years? Like we wouldn't have to do online school, huh? Okay, and then there's the solar minimum and maximum. So remember, every 11 years, the magnetosphere of the sun resets. And that means that you're going to have a lot of activity towards the end of it, and you don't have very much activity towards the beginning of it. And then a solar flare is, of course, when that big energy comes out, and it's kind of like it looks like it's surrounding one of the bands of the magnetosphere. So those are the solar weather. How does it impact the Earth? Well, we basically get all of our energy on this planet from the sun. So like we do some things like we burn coal, but coal is dead organic matter that used energy from the sun before it died. So really, like if you trace it all back, you're going to get to the sun eventually with that energy. Okay, one other thing I really wanted to go over, because like a lot of you kept getting it wrong over and over and over again, is the order of time. And I want you to think about there's going to be a question on the test like this, and it's probably going to be 5 points, so it's a big chunk because it's really important to know this. So I'm going to go to, I think right here, is this where it is? Okay, so this is our timeline of the universe. Okay, we don't really care about all of this part. Well, I mean, I do, I care about it, but it's just not covered in this class. We're going to go over here to the very beginning. So we got 13.82 billion years ago. They didn't put the 2. If you put 13.8, I would still give it to you. But the Big Bang happens. What was before the Big Bang? Look, they have a little question mark. We do not know. We have no idea. Why did the Big Bang happen? Again, no idea. But the Big Bang is the beginning that we can trace everything to. And so everything was packed into this tiny little dot. It was smaller than an atom. So first, psh, bang, okay, the universe starts. Now it's expanding, and then for some reason it expands like at a crazy high rate. That's what we call inflation. Okay, so inflation is when the universe it just expands at like an unimaginable rate. It's just huge, huge, huge. Now, as that's expanding, then we get more opportunities for things to be in there, like because we've got more space in it. We've been there for more time. So what happens is we start to get the nucleons forming. So we start to get protons and neutrons forming. There's also electrons, but the important thing, excuse me, is that the universe is going to cool enough to let those neutrons and protons come together and form the nucleus of mostly hydrogen, but also some helium, because remember, it's like fusion. It's like a star right now. Okay, then what happens, and these are some of the ones that people are getting mixed up, is that recombination happens. Okay, so when we have recombination, those neutrons and protons that were just a nucleus of hydrogen, they collect an electron. So they like fish an electron out of the sea. That positive and negative energy just becomes an atom. And at that time, light waves can be released. So before, all of that energy was just being trapped because there was this positive and negative plasma gas, basically, that was the whole universe. And so the energy was just bouncing around and it couldn't go anywhere. Well, when you capture those electrons for recombination, I know it's called recombination, which is confusing because it actually just means like combination, because before that we didn't have any atoms that were together fully formed. But now that we've fished these electrons out, then the gas becomes neutral. And that neutrality allows cosmic microwave background to release. So these are right on top of each other, right? They look like they're right together. But you have to have those electrons fished out of the universe in order for those radio or microwaves to be released in the first place. So I just want you guys to know recombination happens before the cosmic microwave background. We don't talk about the dark ages, but during the dark ages, all of the gases are like going together. So all of the little hydrogens and heliums they're gravitationally attracted to each other, and then at a certain point they become stars. So stars and galaxies and stuff, that's the last thing to happen on those lists that I'm giving you. Of course, there's more things that occur, like the Earth and the solar system form. We get life on Earth. Is there life other places in the universe? We don't know. That could be cool to discover in our lifetime. But right now we don't know. It's all science fiction for now. So I just wanted to clear that up because a lot of you guys were like super confused on that one. I hope that did.